Jai Hind to all. Myself Dr. Kamal Kumar Mittal from Ajay Kumar Garg Engineering College, Ghaziabad. Department is Mechanical Engineering. Today I am going to discuss about brief of computer integrated manufacturing. So, this is a component or this is a lecture of the course computer integrated manufacturing. In the previous two lectures, we have discussed about the syllabus, the major topics which we have discussed in brief, like computer design and robotics, automation, types of automation, then part programming, then process planning, transformation, then material requirement planning, assembly line balancing, and in lecture 2 we have discussed about automation and its types of automations like hard fixed automation, programmable automation and flexible automation. And we have also discussed how that automation propagates, means revolutions. So, there were 3 revolutions, first, second and third, and then we have discussed about the advantages and disadvantages of automation. So, today in going to discuss about introduction of CIM. So, computer integrated manufacturing, that is CIM, is the manufacturing approach of using computers to control entire production processes. So, this is basically the integration of CAD, that is computer aided design, then CAM, that is computer aided manufacturing, and some business functions. So, integration of all these activities is basically the CIM. So, design activities, manufacturing activities and business functions. So, not only this integration, but this integration also individual processes to exchange information with each part. Means we are having different departments like in a shop floor, like production, maintenance, quality, then HR, human resource, purchase, sales and marketing, etc. So, there are different departments. एक ऑर्गेनाइजेशन में विभिन्न प्रकार के विभाग होते हैं. उन विभागों के बीच में उनके बीच में सूचना का आदान प्रदान सुगम हो सके, that is the benefit of this computer integrated manufacturing, because the people which are working on production area, maintenance, quality, they can see what is happening in the shop floor. They know each and everyone. They know the inventory which we are having in the shop floor. So, how much inventory we are having in the store and how much inventory we have to take from the vendor. So, the purpose of this is the inventory should not be more. So, because if the inventory is more than the requirement, it will occupy the space, means the inventory is waiting to be performed. So, that will consume cost, like we can say carrying cost is there, and ordering cost. So, if the inventory is more, then we have to occupy these inventory, some space is required. So, we have to pay for rent. So, inventory only when desired, when required, then we can place or we can take from the vendors. So, using CIM, production, maintenance quality. So, what is happening in maintenance? There are different type of maintenance activities are going on, like we can say preventive maintenance. Preventive maintenance. So, what is there in preventive maintenance? There is a schedule of the maintenance, like different operations, like we have to replace some belt which is in the motor, some maintenance work on the drive, some replacement of the bearings. So, we are having the ERP, some set of software. So, from this we can easily schedule, and a reminder is coming, so that our machines are on, so that we can maintain the machines. उससे हम अपनी machines को maintain कर सकते हैं, control कर सकते हैं, and we will not lose the production. Means we are having the requirement given by the customer, and we can easily fulfill those requirements. हम उस requirement को पूरा कर सकते हैं यदि हमारी जो machines हैं, system है, वो maintain रहेगा. So, these are the benefits by using the computer integrated manufacturing. Now, this is a complete block diagram of the computer integrated manufacturing. First is the CAD, that is computer aided design activities. Then CAM, activities. This is also, these two are computer aided manufacturing activities. These are computer aided design activities, and these are business functions. Business functions. So, first CAD geometric modeling. So, the purpose of geometric modeling means to create a part that may be a 2D part or 3D part. So, in this just we have to make a drawing of 2D and 3D drawing. Then comes the engineering analysis. So, in this there are different type of analysis, like mass property analysis, then tolerance analysis, then interference analysis, then a finite element analysis, and one more is the kinematic and dynamic analysis. So, these are the different types of analysis that we can do in engineering analysis. These analysis we will discuss one by one in the coming slides. Then design review and evaluation. After these analysis, first we have to make a more part drawing, then analysis, then we have to go for review. Why? Because if we, by reviewing, we are having the RP machine, rapid prototyping machine. From that we can easily make a 3D part quickly. RP machine की सहायता से हम एक 3D part तेजी से बना सकते हैं, and we can analyze whether we are going according to our design or some changes is required. Then go for automation drafting. So, these four are the component of design module. Then comes the computer aided manufacturing activities. In these activities, cost estimation is there. This is again a very important part, because in cost estimation there are different type of machines which require some maintenance. So, some labor cost is there, some salary we are giving to the working people. Then we require some inventory from the vendors. So, carrying cost, so ordering cost is there. So, ordering cost is basically the cost which involves the people which are involved in the ordering, placing the order. Some space is required for performing some documentation, etc. So, that cost is also there. Some transportation cost is there, because the transportation in the goods or raw material. Then carrying cost is there. Carrying cost include the cost of the warehouse where we have to put the inventory. जहाँ पे warehouse जहाँ पे हम inventory को रखते हैं उसकी rent हो सकता है, that we have to, or investment for purchasing some area to keep this inventory in a better place. Some power is required to maintain. If some parts are like very affected by the humidity, then we have to control the temperature. So there are different types of costs is there, and these are all. Then comes the CAPP. CAPP is basically the computer assisted process planning. So computer assisted process planning means computer की सहायता से एक process plan बनाना है. So what is there? By this way we can generate the root sheet. Root sheet means we are having a component that we have to go into manufacture in a plant. So we just send or give the input parameter to the system, computer system or some software, and a root sheet is generated by the computer using artificial intelligence. Then comes the part programming. So like CNC machines, we are having part program. There are different codes are there like G code. These are proprietary codes are there. Then M code are there. These are miscellaneous codes. Proprietary codes are used for like moving like for circular interpolation, like linear interpolation. Different codes are there like G01, G02, etc. Similarly, M codes are there like M01, M02, etc. There are different meaning of these codes that we will discuss in detail in the part programming by taking an example. The meaning of these are like if we have to start the program, different code is there. Start the spindle, start the coolant, stop the coolant. If dry operation is there, stop the spindle, end the program. So different miscellaneous codes are required. Then comes the MRP and capacity planning. MRP is basically the material requirement planning. So material requirement planning means we have an order from the customer. That order we having like annual basis, then we convert that annual order into monthly basis, then weekly basis, then daily basis. Or daily basis we can say we have to fulfill the demand. So 2 or 3 shifts are running. So accordingly we have to plan how much inventory we require from vendors or how much machines we are having. So plan and loading and unloading, all these things we have to do. Then one term comes bill of material, that is BOM. Bill of materials shows the complete subcomponent requirement for an end product. Suppose like bill of material. Suppose this is a product, end product is there, and B, C are subcomponent. These two are subcomponent, and the requirement of this 1 and 2B and 3 C's are required. Suppose we have to make A equal to 100, then the requirement for B is 2 into 100, that is 200, and for C is 3 into 100, that is 300. So these are the requirement for fulfilling the end product demand. Then comes the process control and process monitoring. This is again a part of computer aided manufacturing. So process control means we have to control the output variable. We set the input parameter. So output variable may be temperature as per the requirement. If some thermal affected area is there, we have to maintain the temperature, or velocity we have to maintain, that may be decreasing or increasing. Then or pressure may be, pressure हो सकता है कि हमें pressure को maintain करना पड़े. So that process we have to control. We are having controller, actuator, feedback sensors. Then process monitoring. Process monitoring means if there is a variation in the means control charts, that we can say that we are using different control charts. Suppose we have to generate a cylindrical shaft, so diameter we have to place some ranges there, suppose from 4.5 to 5.5 centimeter or like that, or mm. So we have to fix the range, and we see that if some part is going below or outside this end limits, then we have to find the solution, what is happening and what corrective actions we need. Then computerized business system, order entry, accounting and payroll. These are business functions, accounting, control, payroll, and these all things are done by the help of computer. So this is complete about the computer integrated manufacturing. Now, computer aided design is the use of computers to aid in the creation. मीन्स कंप्यूटर एडेड डिज़ाइन एक हेल्प है जिससे कि हम कंप्यूटर की सहायता से एक मॉडल को क्रिएट कर सकते हैं, उसमें कुछ बदलाव करना है, कुछ चेंज करना है, वो हम मॉडिफाई कर सकते हैं, देन हम उसमें एनालिसिस भी कर सकते हैं और ऑप्टिमाइज़ भी कर सकते हैं जो हमारी डिज़ाइन है. दिस सॉफ्टवेयर इज़ यूज टू इंक्रीज द प्रोडक्टिविटी ऑफ द डिज़ाइनर की प्रोडक्टिविटी में सुधार आता है इससे. इम्प्रूव द क्वालिटी ऑफ द डिज़ाइन इम्प्रूव होती है. इम्प्रूव द कम्युनिकेशन थ्रू डॉक्यूमेंटेशन इम्प्रूव होता है, बिकॉज इन ट्रेडिशनल सिस्टम व्हाट वी आर डूइंग, वी आर मेकिंग ड्राइंग्स ऑन शीट्स एंड it is a very painstaking task to make a sheets, time consuming task. But in case of computer design, we have different commands, like we have line command for drawing a line. We give the coordinates of this line and make a drawing simple line we can easily make. Then we can easily make a circle, or we are having trim command is there. Then mirror commands. These are different commands. These are basically the tools which we can use to make a drawing easily. So by that way, if there is a change is required by the manufacturing department or by any reason, so it is easy to make edit or make a new drawing in the computer software easily, and we can save all those drawings. But in case of traditional system like sheets, we have to prepare a new sheets if small changes is required. So again, some time consuming is there. Sheets are long, and the documentation is very tough. उसका डॉक्यूमेंटेशन करना आसान नहीं होता है. हमें कई सारी शीटों को एक के बाद एक उसको डॉक्यूमेंटेशन करने के लिए रखना होगा. तो दैट इज़ नॉट एन ईजी टास्क इन कंपैरिजन टू द कंप्यूटर एडेड डिज़ाइन. सो एंड टू क्रिएट ए डाटाबेस फॉर मैन्युफैक्चरिंग के लिए एक डाटाबेस बनता है. वी आर हैविंग द input or design parameters in the computer itself. So when we are going to manufacture a component, so the component that system can easily generate a root sheet using artificial intelligence, because the computer having all these documentation in the computer memory itself. So these are the benefit, and this is basic about the computer aided design. Next is this is the flow chart of the computer aided design. So first is the recognition of need. हमें ये जानना होगा कि हमें किस चीज़ की आवश्यकता है, उसे पहचानना होगा. ये नीड किसी एक प्रोडक्ट में कुछ चेंज करना है उसके अकॉर्डिंग हो सकती है, और बेस्ड ऑन सम सर्वे और द फीडबैक गिवन बाय द कस्टमर, या कस्टमर के द्वारा कोई फीडबैक है कि इस सिस्टम में प्रॉब्लम है, इस प्रोडक्ट में प्रॉब्लम है, then we have to change something, we have to add something. So first we know what is the need, because need is to fulfill the customer need. Then definition of problem. जब हमें ये पता चल गया कि हमारी क्या आवश्यकता है, क्या नीड है, फिर हमें प्रॉब्लम को डिफाइन करना होगा. तो डेफिनेशन ऑफ प्रॉब्लम मीन्स दैट डेफिनेशन यू कैन सी दैट बिफोर 70s और 80s देर वर नो ऑटोमेशन. उससे 70s 80s के आसपास ऑटोमेशन का कोई रोल नहीं था. nobody knows what is automation, but the requirement for automation arises. Revolution, first evolution, second and third. So revolution means the purpose of this automation is to reduce the human effort. ह्यूमन एफर्ट को कम करना, आंशिक रूप से ह्यूमन बीइंग का इन्वॉल्वमेंट, मैक्सिमम मशीन्स का यूटिलाइजेशन करना, मशीन्स को ऑटोमेट करना with or without the help of computer system. So, definition of problem means automation means automation, there are different type of automation, hard automation, programmable and flexible automation, and there are different level of automation. Level of automation. So, level means at component level, or at machine level, or at the system level, or plant level, or enterprise level. So, these are the different levels. So, we have to see at what area we have to automate. If component is required, like we have to develop a sensor or actuator. For example, if we are going to some place and come, यदि हम कहीं जाते हैं और तो when we are reaching or approach to the door, it is automatically open and closes. So, some sensor is there. So, or when we are approaching towards an elevator, so as soon as we reach the elevator, it starts moving. So, again some automation at the component level first is required. So, then we have to define the problem at the which area we have to automate. Then synthesis. Synthesis is basically the modeling. Synthesis is basically the modeling. Modeling means we have to create a part simple, which means after definition of the problem, suppose a sensor is required. So, we have to design that, a picture comes in our mind or some modification is there, then we have to make a part drawing of this component. Then go for analysis, then go for analysis and optimization. Analysis that may be related to thermal affected area, then thermal analysis is required. If thermal analysis means if some thermal area is needed, some component that is developed which fulfills the thermal requirement, then we have to optimize this. Then evaluation, evaluation using RP technique, rapid prototype technique. So, we can easily manufacture those components by using rapid prototyping technique. Now, if the evaluation, after evaluation we see that the design is not moving according to the given parameter or given specification, then can the design be improved? Yes, change the design. Then we have to change the design, modify the design. That is again a we can do with the help of computer. It is very easy. Then again go for modeling, analysis and evaluation. If design is cannot be improved, then design impossible for the given specification. We cannot make the design for that specification. Then go for presentation. So, this is flow chart of the computer aided design. So, this is about the brief of computer integrated manufacturing, and in the coming slides or in the coming lecture we will discuss about the design phases, CAD functions, then this geometric modeling in detail, then some classification, geometric modeling classification. There are 4 type of classifications, 2 dimensional, 3 dimensional. Then these are the different analysis part that we can do. Then computer aided manufacturing that we will discuss in the coming slides. Then there are 2 parts, manufacturing planning and manufacturing control, but we can take an example and we can easily understand. So, thank you. This is from my side.